Ladies and gentlemen, it is time to talk expanding polynomials. And what do we mean by that? Now, this is something you've hopefully probably should have seen or come across before, where we've got two polynomials here, or two expressions, and I'm going to multiply them together. And I do that by expanding. Now, you might have learnt different methods. Some people might have learnt FOIL method or the grid method. The way I like to teach it is the splitting the gangs method. And basically all that means is I take one of those polynomials, one expression, and I split it. I split it in its terms, okay? Because I've got a term of x and a plus 2 is a term. And then I take the second polynomial, this expression here, and I multiply each of these by one at a time, and then we pull together at the end. So let's do that. In fact, so I'm going to take my x from here, and I'm going to multiply it by the second expression. And then I'm going to take the plus 2 and also multiply it by the second expression. Okay, hopefully nothing new there. This is something you should have done previously. Now if I go ahead and do those expansions, I do x times 3x, x times negative 3. I do multiply these two, and then I multiply these two. And x times 3x gives me 3x squared. I've made a mistake there. That should in fact be a negative. So look, I'm just going to push on for now because this isn't the one we're actually going to work on. So I made a boo-boo. That should be x times negative 3 give me negative 3x. Shouldn't do these things in a hurry. It looks like the rest is okay. And then you would find the like terms, which in this case are the 3x and the 6x. Tidy them up, but if we did that right, obviously we'd have a different answer. Blah blah blah. Let's forget about that one and get on to the real meat of where we're wanting to go with all this. We can expand polynomials that have more than just two terms. Traditionally, up to this point in your maths journey, you've probably only done it with two, maybe with three. But let's take an example, and we're going to look at a couple of different examples. Where we're going to do the same idea, but we've got some extra multiplications to do, basically. All right, I've got two polynomials. Okay, this is the first one. Here's my second one. I'm going to split. Usually the smaller one is easier to split. You don't have to do it that way. You could split the bigger one, but I'm going to split the smaller one right there. Now remember when you split it that we include the sign. So at the plus or minus sign, that's the start of the new term. So my terms are x squared and negative 1. Each of those I'm going to multiply one at a time by the second expression, the second polynomial. So when I write that out, I get something like this. Now I'm going to go through and just do the multiplications. So if you remember your index laws, when we multiply things where the bases are the same, we add the indexes. So we're going to do that. Okay, x squared times x squared gives me x to the 4. X squared multiplied by positive 2x gives me 2x cubed. And hopefully you can continue to do the multiplications from there for that one. Moving on, negative 1 times x squared gives me negative x squared. All right, negative 1, blah, 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 blah. If I continue to do my multiplications, I get this. Now, nothing new in terms of process. It's very similar to what we did over here. There's just some extra multiplications to do. I get to this point and I've got to look through and see, are there any like terms I can tidy up? Well, I can see I've got an x squared and an x squared. They are like terms. There's nothing else in there that's like terms. So I'm going to tidy up negative 3x squared, take away another x squared, which gives me negative 4x squared for that little bit. So everything else is the same. That becomes negative 4x squared, and nothing else has changed. There are no more like terms, so we are done. We have completed this, expanded this pair of polynomials. There's no more like terms to tidy up. We're done. All right. You may sometimes, however, get a question where there's more than two polynomials or two expressions, something like this. There's actually three in this one. It's x plus 1, and x squared minus x minus 3. So how do we go about attacking these? We do them in two separate parts. I'm going to multiply the first two polynomials together first, and when I'm completed, that will give me a polynomial that I then multiply the second one by. So the first one's nice and easy. X times x plus 1 gives me x squared plus x. All right, all good. So that now is a new polynomial. So I'm going to take that and multiply it by the second one. Okay, so you see I've just done this as one piece first of all to get to this. And now this looks just like something like what we did up here in the top one. So we're going to do the expansion. I'm going to split that gang into x squared and a plus x. So when I write that out now, my multiplication is going to look like this. You'll see with some of these they can get a bit long, but the process, if you just work your way through it, crunch your way through it, everything's going to work out fine. So just take your time, try to avoid making silly mistakes like I did back here, and you will be good. X squared times x squared gives me x to the 4. X squared times a negative x gives me a negative x cubed because it's a positive and a negative. So my answer will be a negative. And negative 3x squared. I'll just keep working my way along. X times x squared gives me x cubed. Negative x squared, negative 3x. Hopefully you can pause if you need to and just see if there's anything in those multiplications that I maybe went a bit quick. Last step, just like we did with all the others, is I look for any like terms. Now, having a look through here, my like terms in this case, I've got a negative x cubed and a positive x cubed. I've also got a negative 3x squared and a negative x squared. So there's two pairs of like terms that I need to tidy up. Now, interestingly, you'll notice that when I tidy up these two, they actually cancel each other out. Right? Because I've got a positive x cubed and a negative x cubed. When I add them together, I get 0. Right? One cancels the other cancels each other out. So they're easy to deal with. They're gone. We don't even have to worry about them. But I do have to tidy up these ones. Negative 3x squared, take away another x squared, will give me a negative 4x squared. All that's left is the negative 3x. We have completed that multiplication and brought it down to this nice, tidy little final polynomial. Whew, nearly done. I want to throw in one extra little weird one, and I'm not going to complete this one, and you'll see why, but we'll get it started. What if you get something like this? Okay, it's a multiplication of two polynomials, so we're going to expand them. But this case, I've got 3 terms in the first one, and I've got 4 in the second one. That's okay. Where I follow the exact same process, except I'm going to split this into 3 separate terms. So I'm going to take this, I'm going to split my first one, and now I'm going to do 3 multiplications. So I'm going to do x squared multiplied by this, plus 3x multiplied by this, and negative 2 multiplied by this. Now, I'm not going to complete this because you'll start to see this gets pretty long, and you're going to need a fair bit of room on your page for it. So if I did the first multiplication, it's going to look like this. X squared multiplied by the second polynomial. Then I'm going to do the plus 3x multiplied by the second polynomial. Then I'm going to do the minus 2 multiplied by that, and you can see I've basically run out of room. But hopefully you get the idea. It'll be multiplied by this. You're going to have this massive, big, long multiplication to do, but it's fine. You just crunch your way through it. X squared times x to the 5 will be x to the 7. X squared times 7x to the cubed will be 7x to the 5. And you're just going to end up this big, long string of terms. There'll be a heap of like terms that you have to go through and tidy up. I'm going to leave that one. If you want to play with that one, go for it. And look, guys, hopefully that is going to give you enough to just show you they're not too scary. There's a bit of work, but you can go ahead and expand massive polynomials. Have fun with it. Good job. Well done.